Black holes in our universe are both terrifying and actually pretty docile. See, a black hole doesn't actually suck material like most people think. It just has a gravity so strong that not even light, the fastest thing in the universe, can escape it. Now that doesn't mean that you should go picnicking around one either. See, a black hole has a sphere around it that determines its size called the event horizon. Passing this horizon would lead to a process called spaghettification, where the atoms of your very body would be ripped apart and eaten by the black hole. But black holes come in all different types of sizes, from microscopic primordial black holes to ultramassive black holes that control entire galaxy clusters. So let's start with primordial black holes. These types of black holes might actually be more terrifying than the ultramassive ones, mainly because they can be subatomically sized, but a black hole the size of a proton would have the mass of Mount Everest. The amount of space that you actually need to compress an object into before it becomes a black hole is actually called its Schwarzschild radius. So this means there could be black holes lurking in our universe, literally impossible to see and have the mass of an entire mountain. But how does a primordial black hole actually come into existence? Well, the answer is actually in the name. See, primordial actually means existing at or from the beginning of time itself. These black holes actually formed at the very beginning of our universe, just a fraction of a second after the Big Bang. The universe in that first second was the most violent and chaotic thing imaginable. There was an unbelievable amount of mass and points with so much density that they literally gravitationally collapsed into black holes. Just to give you an idea of the amount of density and pressure that must have existed in that moment, imagine a giant galactic giant just squishing down Mount Everest to the size of a literal proton. That's the same thing as taking the entire Earth and squishing it to the size of a peanut. Like, these scales are insane. And primordial black holes would actually explain a lot of things that we don't know about the universe. For instance, a leading theory for the cause of dark matter, which makes up over 30% of the mass of our universe, is primordial black holes. And by the way, just visible matter that you see, galaxies, stars, planets, makes up just 5% of the mass of the universe. They would essentially be like invisible glue, holding galaxies together without ever being able to be observed. And that would explain why we can't see dark matter. And since they would have formed at the very beginning of the universe during the Big Bang, it's safe to say they would be at every single corner of the universe. The biggest issue though with primordial black holes is they haven't actually been proven to exist. But also think about it. How could we from Earth observe a black hole the size of a peanut from light years away? It would literally be impossible. It's already difficult to even take pictures of large black holes. One last thing. Far away from the orbit of Neptune exists a phenomena that we haven't been able to explain yet. It's a group of asteroids and comets that have orbits that can only be explained by an object that would have about 10 times the mass of the Earth and would be insanely far away from the sun. Now, a leading theory is that it could be a Planet 9, but a lot of astronomers have a guess that it's a primordial black hole that would be about 10 times the mass of the Earth and just the size of a watermelon, making it literally impossible to observe. But let's move on to some scarier and bigger black holes. Stellar mass black holes are like the average Joes of black holes. Not to say they aren't insanely terrifying, but they're kind of what you think of when you think of a black hole. A stellar mass black hole is created from a supernova explosion of a star 10 times more massive than the sun. A supernova explosion is the largest explosion in the entire universe, often outshining its entire home galaxy, and it's the final stage of a star's life. See, a star is at the balance of two opposite forces: gravity holding the star into a sphere, into the smallest sphere possible, and the nuclear fuel on the inside trying to push outward. Now, what makes a star stable is these two forces being at equilibrium with one another and canceling each other out. See, stars convert hydrogen into helium, and that chemical reaction releases so much energy it gives the star its insane luminosity. But when a massive star runs out of fuel, it begins to cool off. This causes the pressure inside of it to collapse and gravity wins, making the star a black hole. Now, the whole collapse of a star much bigger than the sun can happen in just 15 seconds. Like, imagine a star literally existing for millions or billions of years and just dying in under 15 seconds. Also, usually these stellar mass black holes are in the center of nebulas, which are basically just the star's guts being shot into space. So it's not like they can just creep up on us. Now, the largest stellar mass black hole that we've ever discovered is Gaia BH3, which is about 33 times more massive than our very sun. It's also the second closest black hole called Earth about 2,000 light years away. But remember, black holes are extremely difficult to detect if there's not an insanely bright light source next to them. That black hole, Gaia BH3, has an event horizon of about 120 miles, or just the distance between Philadelphia and New York City. And the way that this black hole is observable is kind of terrifying. See, it has a star that's orbiting around it that's about 76% the mass of our sun. And because of its immense gravity, it's basically tearing that star apart, and the guts of that star are rapidly orbiting around Gaia. That disk of hot and deadly star material is called an accretion disk. And the next type of black holes, supermassive black holes, have accretion disks of not one star, but the gases of entire galaxies. Now, supermassive black holes are where we go from scary to terrifying when talking about black holes. These monsters are usually at the center of galaxies, and they can be on the order of millions to billions of solar masses. The way that the sun is sort of a leader to all the planets in the solar system is the same way that supermassive black holes lead their home galaxy, thousands of light years across. Only 2 supermassive black holes have ever been photographed. The first one is the one at the center of our very Milky Way galaxy, about 4.2 million times the mass of the sun and about 14.6 million miles across, or just small enough to fit in the orbit of Mercury. The second is much more daunting. See, this image you're seeing right now was taken with multiple telescopes on the surface of the Earth and the Event Horizon telescope in space. It's an image of the black hole at the center of the M87 galaxy about 55 million light years away, meaning this image is of the black hole 55 million years ago. Now, this black hole is incomprehensibly massive. It's about 6.5 billion with a B masses of the sun and about 24 billion miles across. That's big enough to fit over 8 solar systems the size of the sun to Neptune, and that's still not even close to the biggest black holes. The way that these gods of galaxies form is not actually known 100%. A leading theory is the direct collapse of gigantic gas clouds, and not uniquely, these types of black holes are called direct collapse black holes, or DCBHs. They're technically referred to as black hole seeds, meaning they're extremely massive but become supermassive by consuming the gas and dust around them in their galaxy. Now, supermassive black holes would have formed about 250 million years into the universe when star formation had just begun. See, there are billions of gas clouds in the early universe that didn't have the correct equilibrium to be stable, meaning that the inside of the gas cloud didn't properly push against the force of gravity that was pushing in on it, kind of the same way that a supernova explosion happens. This led to gravity winning the battle and collapsing gas clouds that could be anywhere from 10,000 to 1,000,000 times the mass of our star. Now, this tiny supermassive black hole that would have formed from that collapse would just be a little bit of a seed to form something much more daunting. See, now that the black hole has a sufficient amount of mass to pull in stars and other material, it can rapidly increase its mass. Now, this is a process that would happen over the course of billions of years, with the black hole slowly eating its way to the top. And this process is sort of exponential. The bigger the black hole gets, the more material it can grab and the quicker it can grow. Eventually, entire galaxies form around these things, and then they have an infinite food source, so they just keep getting bigger and bigger. In many cases as well, these galaxies formed around these black holes can collide and merge with the other supermassive black holes at the center of other galaxies, effectively multiplying their masses and sizes. Now, the merging of 2 supermassive black holes is one of the most violent things in the entire universe, often rippling the very fabric of space-time itself, and radiating up to 5% of the mass of those 2 black holes' energy into space. And the scariest part is that to a telescope or an observer, these collisions would literally be invisible, acting as a sort of invisible storm at the heart of galaxies. But what happens when multiple supermassive black holes collide over billions of years? That's where we take terrifying to incomprehensible. Let's talk about ultramassive black holes. Ultramassive black holes are black holes that are over 10 billion times the mass of the sun. These black holes are cosmic giants and are the largest individual objects in the entire universe. They would have formed in the early universe when massive galaxies would constantly be colliding with one another. Supermassive black holes would have collided with other supermassive black holes, and then more galaxies would have been pulled in, and then more supermassive black holes would have combined to eventually form a terrifying ultramassive black hole. Now, fortunately or unfortunately, Unfortunately, these types of black holes would be very difficult to form now because the prime of galactic formation has long been over. Most black holes nowadays are just dormant, drifting through the universe, not really bothering anyone and kind of just minding their own business. But the craziest part about ultramassive black holes is the sheer size of them. Let's start with the smallest ultramassive black hole. Holmberg 50A is a black hole about 700 million light years away in the center of the Holmberg 50A galaxy and galaxy cluster. The galaxy cluster contains over 500 galaxies, with the one in the very center containing Holmberg 50A. That black hole alone controls a galaxy over 390,000 light years across. That's over 4 times the diameter of the Milky Way. That entire galaxy cluster is basically going around that ultramassive black hole, which is, by the way, 40 billion times the mass of our sun. Just its event horizon is about 1,580 astronomical units across. To give you a scale, Pluto is just 40 astronomical units away, but it gets crazier. Ton 618 is perhaps the most famous black hole in the universe. While it was the largest ultramassive black hole, it has since been beaten by another monster. But don't let that fool you, because Ton 618 is unfathomably large. With a mass of about 66 billion suns, it takes light, the fastest thing in the universe, 5 weeks to cross from one end of its diameter to the other. If the entire solar system from the sun to Neptune was the size of a 19.5mm dice, Ton 618 would be the size of a 64cm beach ball, or about 25 inches. You can fit just under 33 solar systems within its diameter. But Ton 618 won't be creeping on you in the middle of the night. See, it's actually a quasar, one of the brightest things in the entire universe, and it outshines its entire host galaxy. About 140 trillion times brighter than the sun, the accretion disk around it orbits it so quickly that it creates beams of radiation. And in just a fraction of a second, Ton 618 releases more energy than the sun will release in its entire 10 billion year lifetime. But the next black hole makes Ton 618 look like a pebble. Phoenix A star, the black hole, is at the center of the Phoenix A galactic cluster, but it still outshines the entire cluster. It's about 5.8 billion light years away from us here on Earth, and about 100 billion times the mass of the sun. You can only imagine what it would look like from even 10,000 light years away. But I want to leave you with this, some images of what Phoenix A and Ton 618 would look like compared to just our little solar system, the tiny dot in the center. See you in the next one.